Welcome to Summarize Science, where we explore how new technology is changing our world. Today, we're looking at a breakthrough in aviation that uses artificial intelligence to make wings much more efficient. Turbulence is a major problem for aircraft because it creates drag, which is essentially the air resisting the plane's movement. Drag is a primary source of fuel consumption on aircraft wings, making flights more expensive and less eco-friendly. To combat this, researchers want to use reinforcement learning, which is a type of AI that learns through trial and error. However, training an AI on a high-fidelity model of a real airplane wing is incredibly expensive and slow. To solve this, the scientists developed a physics-guided approach to speed things up. Instead of training the AI on the complex wing itself, they trained it in a much simpler environment called a turbulent channel flow. This simplified simulation acts as a surrogate that mimics the physics the AI will eventually face in the real world. They divided the wing's surface into sections and matched each one to these simpler simulations. This method is called zero-shot control because the AI is moved from the simple simulation to the real wing without any extra training. The researchers found that once the AI was deployed, it worked almost perfectly on the first try. This setup achieved a 28.7% reduction in skin friction drag on a NACA 4412 wing model. When looking at the total drag, the AI achieved an overall reduction of 10.7%. This performance actually outperformed the current best industry strategies by a significant margin. Interestingly, the AI discovered its own complex strategies for smoothing out the airflow. It created organized patterns of blowing and sucking air that looked like traveling waves. These patterns help keep the airflow attached to the wing, which prevents the chaotic wake that causes drag. The real magic, however, is in the computational savings. By training in the simpler environment, the researchers saved 4 orders of magnitude in computer costs. That makes the process about 10,500 times more efficient than traditional training on a real wing. This discovery means it is now possible to create specialized AI controllers for all sorts of different airplane parts. Even a small reduction in drag on a real airplane can save hundreds of kilograms of fuel per flight. That translates to approximately 1 ton of CO2 saved for every single long-haul journey. To recap, these researchers used a smart training shortcut to teach AI complex fluid dynamics. This allowed for an immediate transfer of knowledge from a simple box to a complex wing shape. The AI proved to be more effective than standard human-designed controls while being much cheaper to build. This paves the way for a future where aircraft are much more environmentally friendly and fuel-efficient. It also shows that AI can solve massive engineering challenges if we guide it with physical insights. Thanks for watching Summarize Science, and stay tuned for more amazing scientific breakthroughs.